Solar calculation for home usage. Design and calculate step by step. Design and calculation. The solar panel has to be made by best quality and excellent materials. The solar panel system made by several parts. 1. Solar panel. 2. Inverter, change DC to AC or upside down. 3. Battery for saving the electrical energy. 4. Charge control for balance the volts and current. Note, now the hybrid system is a different mode in the market, and it is very useful because the charge control and inverter are in one box. These materials can joining: 1. Electricity. 2. Battery. 3. Solar panels. First step for design the solar system. We have to calculate the power or loads because every equipment is different, then learn the total power to the watts. First step. First, lamp 12 watts, for 6 hours, 5 pieces for in 24 hours, for lighting. Second, 1 refrigerator 150 watts, for 5 hours in 24 hours. Third, 1 TV, 40-inch, 95 watts, 3 hours in 24 hours. Fourth, 1 fan, 75 watts, for 4 hours in 24 hours. Solve the first step. Note, 1.3 is the amount of casualties while doing the system. Some people use 1.2. Both are correct. Second step, calculate the solar panels. The solar panels are different about the size and power generate. Although if the size of the panel going to big, the power will be large. So the panel generate will different for as much as the weather. Then we have to know some formula for calculation. While how many solar panels and batteries need in the system. The total power generate per day show the WP total. The sunlight coefficient is different to every place. We have to use some software or GPS to know the coefficient. For example, in Kabul city the sunshine coefficient is 2.5. Continue the past part. It means every hour the solar panels should be produce 881.5 watts. If we use panel 250 watts. Number of panels. Equivalent. 4 panels of 250 watts. Third step, inverter calculation. First, we have to know about the loads. Start load, it's the meaning the load while first load, start current, is different the second current. For example refrigerator. 2. Ohm load. It's meaning the load or current that first current and second current is same. For example kettle. Note, we have to calculate the power per hour. Afterwards we should increase 25 or 35% of the power. And it's the type of the inverter. Continue the past part. Total power. First, lamp 12 watts. For 6 hours. 5 pieces for in 24 hours. For lighting. Second, 1 refrigerator 150 watts. For 5 hours in 24 hours. 3. 1 TV 40-inch 95 watts 3 hours in 24 hours. Fourth, 1 fan, 75 watts, for 4 hours in 24 hours. Total power. However, the type of 513 watts is not in the market. We have to choose increase type. Example 600 watts. Fourth step, choose the battery type. The recommended type of battery in solar systems is deep cycle batteries, high cycle batteries. In fact, batteries used in solar PV systems should be able to discharge to the lowest energy level and then charge quickly. Dry acid lead acid batteries are commonly used. Also, their capacity should be enough to launch the tools and equipment used in the night and cloudy days. To determine the size of the battery, follow the procedure below. Calculate the total watt-hours of all appliances during the day. Divide the number by 0.85, due to battery loss. Divide the result by 0.7, for discharge depth. Divide this number by the nominal voltage of the battery. Now select the nominal voltage of 12 volts. Continuation of past part, battery type. Note, first about batteries. 1. The batteries used for solar should be deep cycle type. 2. It has to gel acid, or atomic type, deep cycle. 3. The amount of charge and discharge should be high. Power per day equals 360 watts-hours per day, plus 750 watts-hours per day, plus 285 watts-hours per day, plus 300 watts-hours/day, equals 1695 watts-hours per day. Please follow the procedure. Fifth step, solar charge control calculation. The charge of the controller is generally measured in terms of voltage and current capacity. The voltage must be in accordance with the battery and the PV array and also be able to withstand the current of the PV array. For charging machine type controllers, the size of the controller depends on the total input current of the PV that enters the controller as well as the structure of the PV panel, series or parallel. The PV array, ISC, is multiplied by 1.3 as standard to determine the charge level of the short circuit current controller. Charge controller equals 4 times 9.3 times 1.3 equals 48.36 amperes. We can use 50 AM type of charge control. Thank you for your attention.